Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined, it's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy.
The silent crisis.
April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted. The cosmic ray avalanche. Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path, it's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The eternal journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day, Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought.